Welcome and thank you for joining. Today's webinar is a free crash course in natural language processing. The time is currently 12:30 Eastern Standard. We'll be getting started in about 5 minutes to give everyone a chance to join and settle in. In the meantime, I'm curious where everyone is joining from. Please share your name and location in chat. This also helps me verify that chat is working in case you have any questions during the webinar. We definitely encourage questions as this helps ensure you're getting the most out of this experience, so feel free to post those under the questions tab next to chat. While you're doing that, I'm going to cover some brief housekeeping items. I've posted some helpful tips for troubleshooting technical issues. You can find that in the very beginning of the chat. If you have any issues with audio or video during our session, please let me know. A couple of quick troubleshooting steps you can take are refreshing your browser, exiting and re-entering the webinar, joining from a Chrome incognito window, and closing any programs you're not using to free up resources. I'm also going to post this survey link here. It's not mandatory, but it helps us make sure we're continuing to provide quality content. And finally, in the polls tab, you'll find 3 poll questions. Again, not mandatory, but it is helpful for me to tailor the pace of the presentation. So again, you can find those under the polls tab next to the questions tab. So a little bit about me. I'm a data science consultant from Phoenix. I've worked in real estate. I've worked in, I have a pretty large information technology background. I've also done analysis in AI security and getting into supporting local politics as well, doing some analysis for a county supervisor that's running. I'm also looking to do some stuff in the telecoms industry with the 5G rollout. So one of the nice things about data science is it can take you all kinds of different places. And in being able to use these tools, I can go into an industry that I may not even be very familiar with and become extremely informed about that industry. So yeah, there's a lot of very useful things that you can do with data science. And I'm curious, what interested you guys in tonight's webinar? This will also help me tailor things to your guys' interest. And while you guys are typing that up, let's see here. Welcome, Waleed from Morocco. And apologies in advance if I mispronounce anyone's name. Bill from Tempe, Aruna from Virginia, and Spencer from Minneapolis. It looks like they're having a technical issue, so ot.subscriber, peer connection error. The stream was unable to connect due to a network error. Please make sure your connection isn't blocked by a firewall. What browser and operating system are you using? Yeah, that is a possibility. Welcome, Dave from Tampa. We've got a couple minutes left here. We'll give everyone a chance to join and get settled in. And for those who are here, I'm going to give you a link to these slides. This is going to be what we're working off of, and that link will provide you a copy of these slides that you can study a little later, which I definitely encourage you to do. We'll give it about another 30 seconds or so before we get started. So go ahead and pull that up. And once we wrap the session up today, you'll also have access to a replay of this webinar. It should start within a few minutes of the live webinar ending, but if you don't have time to stick around for that, no worries. You'll be emailed a download link so you can download and review it with the slides a little later as well. All right, it's about 5 after. We'll go ahead and get started. For those of you who have just joined, a couple things I want to draw your attention to. At the very beginning, there's some troubleshooting steps. If you are having any issues, there's also a link to today's slides up there as well, and a survey link as well, so fill that out if you'd like. So, quick introduction for Thinkful. For those of you not familiar, we're a school who train web developers, data analysts, data scientists, and product designers. The two methods we use this are one-on-one mentorship and project-based learning. Every student is paired with a mentor throughout their entire program, and they will meet with you twice a week to review projects, go over curriculum, and give you the expert support that's been tailored to you. You'll also graduate with a portfolio of 6 to 7 projects built from scratch, so you'll be prepared to begin your job search right away. This is really important because project-based learning is the essence of what potential employers are looking for. A lot of times these days, they're definitely interested if you have a degree or something like that, but they want to see your projects. What have you done? And Thinkful's approach with project-based learning will populate your GitHub with projects that you've built from scratch. So this will assist with the job search. And that is also important to Thinkful because of their guarantee. If they can't land you in a data science job within 6 months of graduation, you get a full refund of your entire tuition. We'll leave a little room at the end to answer any questions you have about Thinkful or our programs, but for now, we'll go ahead and get started with our workshop. So we'll start by kind of taking a very high-level view of the content we're going to be covering tonight. We'll talk about the rise of data science. We've kind of seen an explosion in this role in the past 10 to 15 years. Data science goes back further than 10 to 15 years, of course. It's kind of the intersection of computer science and applied mathematics, so statistics, probability, linear algebra, things like that. But for a long while, it was essentially just a very academic endeavor. And as we got out of the dot-com bubble and you started seeing the internet giants emerge, they invested heavily in data science, which made sense for them because they had all this data laying around and they needed ways of organizing it, managing it, and drawing new insights. And of course, as those companies took on more and more people and trained more and more people to do, perform that role, a lot of very useful open source tools started falling out for everyone to start using. And of course, in the past 10 or so years, that's really, really ramped up. So basically what a data scientist does is generate value from all the data that they have access to. The process of that is essentially wrangling the data. So this is going out and finding data and cleaning it up, processing it before you run any models or anything like that. We'll get into a little more about that a little later. Then, of course, you have analysis. This is the step that you take once you've pre-processed all your data and everything's clean, and now you want to try and understand that data as much as you can using the tools of data science. And then predictive modeling is one of the things that you'll frequently be doing as a data scientist. So you're wanting to take some amount of past information and apply that to make some fairly accurate prediction about the state of something in the future. You can also use this to maybe reconstruct what's occurred in the past, given limited information, almost like a forensic analysis. And then you can also do things like classifying. So if you're, say, looking at a video feed and you want to classify if a person has walked into the frame, if you want to identify whether it's a unique face or not, whether you want to identify whether it's an object like a bicycle or a car or a license plate or something like that. These are all classification problems. Another good example is in the finance industry. If you're looking at financial data, maybe spending data, and you want to be able to classify abnormal, like anomalies, like fraudulent spending, that would also be another classification task. So those are some of the things that data scientists do on a day-to-day basis. Tonight, we're going to be looking at natural language processing, or also called NLP. NLP is a tool that we use to analyze text or human language in some structured way. So it's the basis for things like chatbots, Siri, and the Turing test. Lots of challenges left to solve in this space. With the advent of modern data science tools, we're uncovering more and more of how language works, how social interactions work, things like that. And it's really helping us kind of uncover what exactly social media is. So there's a lot of things left to be figured out, which in my opinion makes it a very exciting aspect of data science, like many others. This stuff is very accessible. It doesn't take a lot of resources to get involved and even start doing original research. And it's easier than ever to share things that you stumble across or find or build. And you can get a lot of feedback from people who find those things useful. So very exciting times. So one of the applications natural language processing is able to perform is figuring out sentiment. This is called sentiment analysis and refers to the process of identifying and categorizing opinions expressed in a piece of text, especially in order to determine whether the writer's attitude towards a particular topic is positive or negative or neutral. It could be a topic, a product, a service, any of those things. If you want to understand how a group of people are perceiving those things, then you would want to look at using natural language processing. And that's essentially what we'll be working on tonight. So we'll be coming up with one big question, and we'll see if we can use data science to figure out how a customer is feeling giving a data set of hotel reviews. So then we'll take this one step further and see if we can use that data to make predictions about new reviews regarding their overall sentiment. So ultimately what we'll be building is what you see here. A text analyzer to look at hotel reviews and analyze the sentiment of the review. To do that, we're going to need three things. We'll need a set of vacation reviews, a text-based predictive model for sentiment analysis, and then we'll need new hotel reviews to feed into that model to get our predictions. So the data tonight is a sample of reviews of 1,000 hotels. This has been collected by Datafinity, and it's available on Kaggle here if you follow this link. I highly recommend checking Kaggle out. Not only do they have competitions where you can win money, but they have some really interesting data sets that are essentially freely available. Many of them are already pre-processed. They give you a lot of information about the data sets. So I highly recommend checking out Kaggle if you're interested in learning more about data science. It's a great place to find information that you can feed through some of the tools we're showing you here tonight. And it's a good opportunity to kind of play around with those things and see what goes right, see what goes wrong. And it's a very excellent way to learn. So the data set that we're looking at is going to have information about the hotel, so the name, location, information about the reviewer, the review text itself, and then a categorical rating from 1 to 5. So when we're using, when we're processing text, it can be very time consuming. So text processing is slow and involved. This way we can make a model and perform matching a relatively quick amount of time by using some of the tools I'm going to show you. It still does take a lot of attention, especially with unstructured data, and you'll kind of get a feel for that as we go through it. 1,000 entries really is not a large amount of information in terms of data science, but it is manageable in the environment that we're going to be using. So it'll give you a rough idea of how these things work, but you can imagine applying these tools to a data set where you maybe have millions of entries or maybe even hundreds of millions of entries, and being able to use these tools to dig through that can tend to take a lot of time. It's almost as if we've gone back to the days where programmers had to wait a really long time to wait for their code to compile. And then of course any errors or mistakes or anything like that kind of set you back, and you had to recompile. Of course, Python is an interpreted language, so we don't really have to deal with that. Any errors we have, we know in real time. We don't have to wait for it to compile. But in data science, when you're working with very large data sets, there can be a lot of downtime waiting for things to process. So, there's always a search for better and more efficient ways of doing things. And that's another reason why there's so much left to do in the space, as these things are relatively new and we're still discovering a lot of the best ways of doing things. So another thing that makes dealing with text data time consuming is the pre-processing phase. As I mentioned, unstructured data is just kind of what it is. And this is due to the fact that when you grab things from the internet, you don't necessarily know if maybe someone's being sarcastic or someone's being genuine, or maybe there's typos, or maybe there's, all kinds of different things that can go into making unstructured data very difficult to deal with. A lot of the models you deal with as a data scientist have very rigid restrictions on what you can put through that model meaningfully. So a lot of time and attention has to be paid to how you're going to clean that data up. And everything that we see on the slide above falls into the category of unstructured data. So, you have kind of a text string here. You can imagine these paragraphs. When you start to think of all the different ways that you could retype this paragraph and still convey a somewhat similar idea, you can start to get an idea of how complicated natural language processing can become. So before we talk about how to clean the text data up, let's take a look at structured data so that we know what we're trying to achieve and we have something to compare to. So here's a simple example of structured data. It's easiest to think about it as a table or an Excel spreadsheet where we have clearly defined categories or headers or attributes, and clearly defined rows. All of the types of data match the categories. You can kind of see that comparing this and comparing this, there's going to be similarities between these two data points that this one and this one don't share. And that's kind of how you want your data organized, right? And this is why we call this a relational table or a relational database. Every data point in a column is going to be related in some way, and every data point in a row is going to be related in some way. So in this case, the way these categories are related are they are a name of a natural person. Well, in this case, two fictional natural people. But they're supposed to identify an individual. And these are all related by the fact that they're emails. So having something like just yahoo.com rather than arthur@yahoo.com would be inappropriate for this schema, because that's a website rather than an email. And when you run across something like that, you need to consider maybe we need a new category. And then all these things are dates, of course. And the way that they're related by row is that this information is all related to this person. This is this person's email. This is the date that they signed up, so on and so forth. So you can kind of view the intersections of the rows and columns as, the relational information that you can look through in different ways. So let's get back to tackling this challenge. First, we'll start with an example sentence and work off of this. We're going to be using the sentence, this is our test sentence. And dealing with unstructured data raises some unique issues, and we want to be able to answer these questions. So any suggestions? I'll give you guys about 30 seconds to think of some ideas and type them out. So what are our data points? How do we compare those data points? And what parts of the data matter when we're looking at our test sentence here? So if this is our unstructured data, we want to identify what the data point is. We want to see how we can compare those data points, and we want to see what parts of the data matter. So I'll go ahead and give you guys about 30 seconds starting now. About 20 seconds left. About 10 seconds. All right, so in terms of the data point, the things you'd want to consider are, when you look at this, what are the unique points that are kind of separate? We can separate this out by word, we can separate this out by sentence. There's different ways we can look at this data. And The way we can compare that is by, maybe grouping words. Maybe there's sentiment here. Maybe there's sentiment here. It's not just a test, it's our test. It's not just a sentence, it's a test sentence. So we can kind of compare words with respect to what other words appear around it. Finally, the parts of the data that matter, maybe isn't very important. Maybe this isn't very important. Maybe this period here isn't very important. We're just trying to get down to the meaning. So we'll look at a couple of ways. So let's see here. So for now, we're going to say that words matter. That's kind of the lens that we're going to analyze this through, because one, it's kind of what's going to give us the highest resolution. I mean, we can go down to the individual letter, of course, but it's almost too high of a resolution. A lot of it can be unnecessary. And part of that is because the English symbols, the letters in the alphabet, they don't have any inherent meaning in and of themselves. They're basically just variables or placeholders that we arrange in certain ways, and that's where the meaning emerges from. So in this case, the word would probably be the most important. We can look at it as a sentence. Maybe if we had thousands and thousands of sentences, we could analyze it that way. But again, you're losing a lot of resolution by saying that this is one thing rather than this is one thing. And the second reason is that syntactically, it's much easier. We have a very convenient character that can break all of these things up, and this is very easy to do in Python. So we'll take an example of how we can structure this data. So this method marks the presence of words as a value count. 0 is for absent, and 1 for each time that word is present. So naturally, our headers are all the words in our test sentence, and then our data points would be wherever that word occurs. So we're looking at this first sentence. We've chosen the word to be the individual value, and then we're keeping track of how frequently that value occurs, if at all. So now let's take a look at how we can use this method to compare between other data. Let's add in a second sentence, and this is a second sentence. And what we're doing here is looking at the words in the second sentence and comparing them to the header words. So we assign a value of 0 if the word does not appear in the second sentence, and the number of times the word occurs if it does appear. So we don't have any instances of this. We don't have any instances of R or test. So right off the bat, there's should be a little bit of a paradox emerging in the back of your mind. Like these sentences have a lot in common, just intuitively as a human being. If you go through and you read this and you say, yeah, they're both talking about test sentences. They both contain a lot of similar meaning. So why is our model not matching up with that? Well, the simple way to put it is the map is not the territory. The thing that represents a thing is not that thing itself, right? So this should be an indication to you as a data scientist that this might not be a very accurate model for how to compare these things, but it is a start. So we've basically found some way to structure our data, but we notice a couple of flaws. So this method is basically called a bag of words approach, or vectorizing. So we make a bag or a column for each word in our sentence, and then we assign a value of the 0 or the 1, whether the word appears or not. And we keep track of the number of times that it does appear when it does appear. So the words in columns are essentially word counts. So we took our initial sentence and created a bag of word for each, and then we counted the number of times we found a word that matched, and then we set that the words are the columns of the original sentence, and then the rows are the value counts. So again, looking at our example, things are a little logically off. We intuitively know that these sentences are related, but our model is not reflecting that accurately. Any guesses of what we might do? Well, one, any guesses of why this isn't a very good model? If there's anything that stands out to you that might not make any inherent sense. I'll give you guys about 30 seconds to take a guess. $20. 10 seconds. Excellent. Aid suggests case. And that is absolutely one of the limitations of this model. You can see that this and this both appear in both of these sentences, but it's not counting it as similar, because when you talk to computers, things like case could matter. And when we're comparing this, we realize that these are technically different things, even though semantically they're similar. So, if you could somehow strip out the case, then this would have been caught and it would have been added in here. Anything else? Any other suggestions? I'll point your attention to this here. And we can see that we have sentence here, and each sentence is only getting one count for using the word sentence, but there's 3. Duplication of the second line. Any guesses on what may have caused that? So basically, just like the capitalization, if we separate it out by white space, you can see that all of these things are separated into continuous words. And then when we separate this by white space, what you can see is that this doesn't have the same punctuation as this and this. So it got left out. And because our model is only looking at the original sentence to compare, this essentially got left off. So if we fixed the capitalization, you can see that our model gets a little more similar. And if we fix the punctuation, so we flatten the case and we drop the punctuation, you can see that this would now have 2, and you can compare the values of these numbers, and you see that the model is becoming a little more accurate. And that's why a lot of times in data science, it's important to just start with some model. You are going to see where it's rough and see where there's improvement. And eventually, when you do that enough, you'll start to get an intuition for these things. You'll know the process of, okay, anytime I'm dealing with text data, I need to drop the case, I need to drop punctuation, figure out how to separate things out. So in order to make all the words equal to the program, we'll make every letter lowercase. And now when we look at our table, we can see that the value count has increased, and everything is corrected here. So we have a much more similar semantic analysis. And additionally, there's a concept called stop words, and basically, kind of getting into what we were discussing before, is important for this, the sentiment of the sentence. Is this important for the sentiment of the sentence? They don't really tell us anything. They're more like verbal syntax, because human beings can only interpret so much information at a time, and people can tend. If I were to just give you raw sentiment with no syntax, it'd be very difficult for you to parse that. We kind of need pauses and spaces in between to stitch things together so that we understand the broader concept. And again, these are essentially called stop words. So it is all of these things are usually just thrown out because they're not actually adding meaning to the sentence. They're just an emergent effect of how humans communicate naturally. But computers know very little of what to do with things like that. So now when we drop our stop words, in this case, they still kept this, and that can depend. In this case, it's probably appropriate because it's, possessing, who the sentence belongs to or who the sentence is referring to. But now you can see that these are they have much more similar scores. So we're going to be using a naive Bayes model to generate our predictions. This is going to use probability and Bayes theorem to predict an outcome. And Bayes theorem describes probability of a feature based on prior knowledge of conditions related to that feature. So it's a way of taking information that we know is related to some outcome and allowing us to adjust our probability based on that related information. It can seem a little arbitrary, so we'll take a quick look at an example on the next slide. So, if you just kind of, not thinking about this computationally or anything like that, if you just kind of read through and ponder this for a minute, I want you guys to take about 30 seconds to just look at this and then make a guess as to what this sentence would be tagged as, sports or not sports. So I'll give you about 30 seconds starting now. Good, about 20 seconds. About 10 seconds. All right, yeah, exactly. Intuitively, it could be very easy to look at this and classify this as sports. Now, you can make an argument that it maybe, might not be referring to sports. Maybe it's a politician saying this and they see their field as a game, and they could be talking about politics. One could even argue that politics is sports. Who knows? We kind of come up with these symbols, these labels to describe our world, and there's always some inherent imperfection about it, but we know enough about what we mean. And so, you can see that, it's very easy to start, going down rabbit holes in data science. And that's why it's usually a good idea to just limit your conclusions to the data that you have in front of you. And if you get anomalous conclusions or you get things that don't quite make sense, that's usually a good indication that you need more data. But if we restrict this to what the data we have in front of us, you can very easily categorize this as sports. And that's essentially, what naive Bayes is. It's a probabilistic classifier. So we want to calculate the probability that a sentence, a very close game, is sports, and the probability that it's not sports. So then we take the largest one, written mathematically. What we want is the probability that the tag of a sentence is sports, given that the sentence is a, quote, very close game. So for today, we won't dig too deep into the math of calculating those probabilities, but know that that's what the model is calculating for each instance in our historical data. It's not supposed to be just a 100% binary certainty that this is what it is. It's supposed to take in the information and give you some continuous value between 0 and 1 of the probability that this thing is related to a tag or another thing. So multinomial naive Bayes is a specialized version of naive Bayes that is designed more for text documents. A simple naive Bayes would model a document as the presence and absence of certain words, whereas a simple naive Bayes would model a document as the presence and absence of particular words. Multinomial naive Bayes explicitly models the word counts and adjusts the underlying calculations accordingly. If you're curious about a much deeper dive, I can provide you a link. So I recommend you check that out and read it after the webinar, and that'll give you a little more information. So today we're going to be using a version of IPython notebooks or Jupyter notebooks that is hosted by Google. It's called Collaboratory. If you click on, let me clean some of this up here. If you click on this link here, which I will copy into the chat, it'll open up a new tab. And you'll notice that you can't really change anything in this. That's because this is kind of our original copy from which all copies derive. And the way that you can get your own copy, and I encourage you to do this, is click on File and Save a Copy in Drive. File is going to be in the upper left-hand corner by the Colab logo, and then Save a Copy in Drive is about halfway down. So once you click that, you'll get a little notification here saying create a copy, and it will open a new tab. Now, if anybody had any issues opening Colab, or opening this link, it might be that you need to sign into Google. If it's the first time you've used it, Google might walk you through how to set the application up so that you have access to it through Google Drive. So go ahead and do that. If anyone has any problems or issues, feel free to let me know, and I can take a minute to help you troubleshoot those. So following this link will give you the original copy file and save a copy in Drive. We'll open a new tab, and now you'll notice that you can edit this. This is an isolated little Linux environment that Google is hosting specifically to run Python. And you can see we've got our little directory here, and anyone familiar with Linux will notice that this is the Linux file structure. For those of you using Windows, and it may even be similar in Mac, because OS X is Unix based as well. And if you're in Windows, this directory here, you could consider this to be like what's in your C drive. It's kind of the root directory. And under content and sample data, you can see that we have some files in here and things like that. A couple of additional things about Colab for you to use on your own. We won't need to be adding any code blocks or text blocks now to go through this workshop, but for your knowledge, so that you can kind of play around in this environment later, how you add code blocks is the plus code button here, and how you add text blocks is the plus text button here. The text can be edited by double clicking, and you can see that this is essentially just Markdown. If you've used Reddit or any kind of forum like that, or if you're familiar with HTML, you should have an idea of a markup language. The syntax is a little different because it's more generated for like forums and things like that, so it's not very technical. But if you wanted to like bold something, you can click bold. You can change the font sizes. You can do all kinds of stuff, and then it'll appear that way down here. So when you're done editing, you can close that up, and it will go back to just being notes. This is a really useful tool for data scientists because, like other scientists, we're expected to document our work and our process and our results as we go through. And it can be very difficult to convey the work that you've done to peers just by having like a terminal environment and a text editor or other IDEs. And with this, it allows you to give more than just comments. You can really drill down into granularity of what your process was. And it keeps things linear, so you can kind of go through line by line and see like, okay, this is what was done, and here's the context and all of that stuff. So it makes it very easy to share things. Let's see here. Anything else I want to cover? So I keep my theme in dark mode. If that becomes an issue at all, I can change it to light. If you would like to change it to dark mode and save your eyes some bright white stress, if you spend a lot of time in front of the computer, I recommend switching it to dark mode. It'll definitely make it a little easier on your eyes. Any questions before we move on? Any issues? All right. So let's see here. There we go. All right. So throughout this notebook, we'll be exploring some foundational concepts regarding NLP, and then we'll apply them in our project down here to analyze the sentiment we have for the hotel reviews. Anytime you see a line with triple asterisks around it, like this here, this is going to be a signal to you that this is an opportunity for live code. A lot of times, these are going to be just exposed, and if you try to run this, it'll give you an error. If you want to run it without contributing anything, actually, I wonder if that'll, yeah, it's, you can just kind of comment out a line. It's going to tell you that, in this case, it's still going to give you an error, but it's not a bad idea to expose you guys to these. So I'll do that now. So if we just run this, it's telling us that this is a syntax error. So Python is telling us that it doesn't know what to do with these asterisks, and that's because there isn't really any rule to tell Python what to do when something just starts with an asterisk. We can make this a string, of course, by using single quotes, double quotes, or triple quotes. And now if we run this, it'll just print out what we have here. And of course, you can change this. So if you go to do something like hello world, and now we run this and print it, you can see that it's printing out hello world out of the terminal. So basically, for those of you not familiar with Python, the way we read this is we're taking the variable x, we're using our assignment character, the equal sign in Python, the single equal sign, and we're assigning the string hello world to the variable x, and then we're using Python's inbuilt print function and passing the argument x to that. So we've passed the variable x to print, and Python is basically going to unpack what x is pointing to. So in this case, hello world. So you can see, very quickly how we can take more information, and then we can compress it and abstract it into less information, and then we can do things with that without being overwhelmed with all of the many things that a variable can represent. So it's a way of simplifying things so that we can do operations on them by following a few simple rules, and then we can do things like print out hello world. So the next thing we'll cover is importing the packages that we'll need. So one of the things that makes Python really easy to use and particularly well suited for data science is all of the different libraries that exist. So we're not having to reinvent the wheel every time we want to, say, handle large amounts of information, like from a database or from a large spreadsheet, or we don't have to hand code our models. We can just have a library like sklearn to have those things pre-built, already be built to the best specifications that the engineers can build them to. So sklearn gets used a lot for machine learning models. Regex or RE is basically like text algebra. It's a little easier to show than to explain, and it's definitely a tool you want to use with caution because it can get very complicated very quickly. But sometimes you just need to use regex, and it's very simple to access in Python. Then we have matplotlib.pyplot, and just like with pandas, you can see that we're importing pandas as PD. So we're doing the same thing with matplotlib.pyplot. We're importing it as PLT. And this is essentially a way of importing a library and shortening it through a symbol or an alias so that we don't have to type out matplotlib.pyplot every time we want to refer to that library. We can just type PLT, or we can just type PD. Of course, this is arbitrary. You can change it to whatever you want, but the convention of these libraries are PD and PLT. And it is a good idea to generally follow conventions, because if you are working as a data scientist, it's very likely that other people are going to have to read your code. So, when people can do that easily, they tend to like you a little more. And not having to, kind of figure out what your code means by giving them things like comments, by having, if you are using something like an IPython notebook, having, proper text boxes that describe what's coming next. If you make things a little shorter, it's easier to read out. And if you're interested in that, I'm going to direct you to the PEP8 style guide. So PEP8 is a style guide for Python specifically, and it runs you through some of the basic rules. So it's kind of a way of giving people suggestions of how to write code that's neat and efficient and organized, so that other people can read that and follow those conventions and understand very quickly what your code means. As you can see, it's very lengthy and in depth, but I highly encourage you to maybe look up a YouTube tutorial. I'm sure there are many out there, and just familiarize yourself with it. There are a lot of good habits in here that if you follow will not only make programming easier for you and make you a better programmer overall, it'll make it much easier for you to work with people. So one of the PEP8 conventions is you don't want to exceed 80 characters wide. And if you have to, Python gives you the ability to start out a new line. Now, sometimes it's unavoidable. It's not a rigidly enforced rule. No one's going to think you did anything improperly if you made an attempt here to kind of cut this out and shorten it up so that it's within that 80 characters. But if you're a few characters over, it's not usually going to be a big deal. So yeah, and then I forgot to mention this last line of code here. So this matplotlib inline with the percentage sign in front of it, this is a thing that's specific to this IDE, where we want to say anything that matplotlib plots so any of the visualizations that we're going to run through matplotlib, that's what that library does. It provides like charts and graphs. Anything that is displayed, we want that to display inside of the Colab notebook. So we'll go ahead and run this. And there's two ways to run a code block. You can hit this little play button here, or you can hit Control Enter on your keyboard or Command Enter on a Mac. I believe it's Command Enter. If I'm wrong about that, and any of you have Macs, please let me know so that we can get the correct hotkey. So yeah, so basically that's a quick overview of the libraries we're going to be using. Again, Pandas is something that we're going to be using for data wrangling and analysis. It's going to allow us to, deal with large amounts of data and manipulate it. sklearn is where we're going to pull our model from. regex is what we're going to do. Well, I'll explain that a little for you a little later, but we're essentially going to be doing text parsing with it. And then matplotlib.pyplot is going to be for showing visualizations about our data. So the next thing we want to do is import our data set. And Pandas can work with a wide array of different kinds of information sources. Below, you'll see that we are pulling it from a CSV that is pointing to GitHub. And all we're doing is passing, I'm going to shorten this up here just for your guys' benefit. You can see that this is all one related concept. So we have a variable called data. We're setting it equal to PD, which again refers to our pandas library, pd.read CSV. So read CSV is a method inside of pandas that allows us to pass an argument that tells pandas where that CSV exists, and then it'll go pull that CSV into this variable as a pandas data frame. So I'm going to go ahead and make things a little less abstract for you guys. So if we go to this GitHub link, you can see that it points to the URL that boils down to a CSV. Now, if we drop this and we just go here, hold on here. Yeah, I think that's what the issue is. There's a redirect in here somewhere, so I'm just going to fix that up. Oh, maybe this isn't publicly accessible. Anyway, the important part is that this essentially exists in a file directory on a server, much like the files on your computer would exist on your computer, right? You have your C drive, you have your user drive, you have your documents or your user folder, you have your documents folder, and then there's documents in there. This is very similar to that, and we're just referring to a file called hotelreviews.csv. And you can see a couple of HTML artifacts in here where the browser's having some trouble processing what things mean. But overall, you can see that this is essentially, every line is a line of values that is separated by commas. So this first line here is headers. And then between the commas, you see the values that correspond to that category. So in this case, our address, this is the address here. The category is a hotel. The city is Mableton, so on and so forth. So this is essentially a comma-separated value document that is being brought into Pandas via the read CSV method. We have to pass this as a string, and I'll show you guys what it looks like if we don't pass it as a string. Any guesses? Off the cuff? All right. So when we run it, basically what it's telling us is a syntax error. And it's telling us it's an invalid syntax because just like with the triple asterisk above here, Python doesn't have a way of just interpreting this. So once, it says, okay, I'm going to set up this variable for you. Okay, I'm going to set up pandas and the read CSV method, and you're going to give me some information to know what to do with that, and I don't know what to do with it. And Python's way of expressing that to you is by telling you that it has an error. So the reason why it's an error is because Pandas requires the path be provided as a string. Again, you can use your double quotes or single quotes or triple quotes to do that. But once you do that properly, it's going to stick all of this information that we saw here into this variable data. And it's going to do that by converting all of this information to a Pandas data frame. And the data.head method is what's going to allow us to verify that the data that we've imported matches the information that we're expecting to look at. So kind of look at this here and say Riviera San Nicole, go back to our code and we can say Riviera San Nicole. Usually you'd want to go through and match up a few data points just to make sure, but we won't do that for time purposes. But essentially what you have is now the first three entries indexed as 0 of the first 3 rows of your data frame. Now you can pass larger values in this, and it will pretty much give you as much as you want or as much as your computer can handle. And it also can take an implicit argument. So if we type out something like 10, that's what we would call an explicit argument. We can pass an implicit argument, which is basically a default value that's hard-coded into the method so that if you don't pass anything, you run it, and there's a value that's still going to return some data. So in this case, the implicit value here is 5. And if we put a 5 in here and we run that, you can see that we get the same number of entries back. Any questions so far? Any errors that anyone's gotten? Anything like that? And as I'm going through, I definitely encourage you, if you try to run something and you get an error or you have a question or a problem, feel free to just contribute that to chat, and I'll address it before moving on to kind of the next area of the subject matter. So the next thing we want to do is check the size of our data. We can do that using the shape attribute. So unlike the head method where we have parentheses and we have an argument that's being passed, or whether it be explicit or implicit, you can see that data.shape does not have that, doesn't have the parentheses. So the reason why is because shape is an attribute of the data and head is a method for the data. And so the methods are going to be what allow you to request information specific to the data set. So you can see that this is information that's actually in the data, or do processes on the data. So like read CSV, we're taking information and we're converting it to a data frame. An attribute is, you can think of it more like metadata. So given this information, we can run this, and now we can get information about how much data we have, and specifically the shape of that data set. So it's going to be 35,912 rows by 19 attributes. So there's 19 of these categories here: address, category, city, county, latitude, longitude, etc. And just a little note on data science jargon. So because data science is an intersection of multiple disciplines, so computer science, applied mathematics like statistics, linear algebra, calculus, things like that, all of those fields have kind of developed slightly different jargon for the same thing that they're talking about. So you do end up dealing with a lot of extra jargon in data science. So some people might call these just columns. Some people might call these categories. Some people might call them attributes. All of those things mean the same thing in data science. So it's a good thing to know that because it can be very intimidating to learn data science when you realize how much jargon there is. But a lot of the times, you can have duplicate jargon because it's pulling from other disciplines, that you can just kind of learn that those words all mean the same thing, and it'll, tend to cut out a lot of research for you. So this is a very simple example of that. So we've got 19 attributes or columns or categories, and then we have 35,912 rows. So these two things, the head and the shape, the head method and the shape attribute, these are good things to do just because it gives you an overall view of what it is you're looking at. It allows you to confirm that you have in fact imported the correct data set and that is what you are working with. It can be very frustrating to maybe, if things are named similarly and you are looking at different versions of data or something like that, you can just assume that you're working with the right one and go do all this analysis and then run into these really weird anomalies and have to spend time troubleshooting and tracking that down. It can get very, very time consuming, only to then find out that, oh, you accidentally referred to the wrong information. So running the head method is going to give you kind of that precursor. You can kind of go through a few values and say, yeah, okay, I've confirmed that I'm using the information I'm expecting, and I know how large that information is. We're not going to be worrying about using all of the different columns for this project. That's another thing you're going to do as a data scientist. A lot of times, you're going to establish your question, and you'll have a data set, and you're not going to need everything. So what we're going to do is pare that down and only look at the things that are relevant to our question, which was. I believe it was whether we can determine the sentiment of a customer review. But yeah, so all we really need is the name, which is, I believe, referring to the name of the hotel. We need the reviews dot rating, So reviews dot rating. So this is going to be a float value that gives us information about how people rated the hotel numerically. And then we have our reviews.text. I think that's all the way. Oh, it's right here. And then we have our reviews.text. So everything else we're going to drop. And the way that we do that is, so let's start by this. So this is an opportunity for some live coding for you guys, but I'm going to show you something real quick. So I'm going to put a comment in front of this. So in Python, to comment things out, we use a hashtag. And what that allows you to do is basically tell Python that this is more just human readable. You don't have to process this. So if we run this, you can see that it returns our data as it appears, just the information that we're looking for. So we have the name, the reviews.rating, the reviews.text. But if we now run, comment this out real quick, and we run, whoops, data.head again, you can see that all these things are still here. So what's going on here is that when we run something like data using our double square bracket notation, and let me fill you in on that a little bit. So Pandas uses square bracket notation to allow you to pass values to the data frame to select columns. So in this case, to pass multiple values, we're using a list. So in Python, lists use square bracket notation as well. And lists allow you to have many objects separated by commas. And we're passing that list to Pandas, which also coincidentally uses square bracket notation. So these double square brackets, they technically mean different things, but for you to just wrap your head around it, you can just consider this to be double square bracket notation, and that's going to be an acceptable thing for Pandas to allow you to select multiple columns. And all we're doing here when we run this and not this is we're just basically doing a query. We're telling Pandas, I just want to see this data. It's not actually changing the variable data. It's just showing you information about it. So given what we know about creating variables and setting variables equal to things, can any of you come up with a suggestion on how we would want to update this variable such that all the other attributes or columns that we don't care about are now dropped and our variable only equals these three things? Give you guys about 30 seconds to look at things and consider that and make a suggestion. About 20 seconds. About 10 seconds left. All right, so the way that we're going to do this is we're basically just going to reset the value equal to itself. So Python's going to process this first and say, okay, you just want to see the name, the reviews.rating, and the reviews.text. And then it's going to process that we're taking that output that we saw earlier. So taking this output here and then sticking that into the same variable recursively. So now, oops, not the data. So now when we do this, we get nothing. And curiously, that output is noticeable. You know, it's like, okay, we ran one thing, nothing came out, and now we modify this and we don't get any information back. The reason why that's the case is because we have to return the variable. If you simply just assign something to a variable, it's not going to return anything. So you have to then return it. So if we set this equal to data and then we run data, you can see now that what we're getting back is the same thing. And more importantly, if we do data.head, you can see now that we only have these three columns. So the next thing we want to do is make our data a little more consistent. You know, being able to take pre-existing information. We kind of didn't really have a lot of control about what, how things were structured, how things were named. We have a data source, we pulled it in, and maybe we need to make things a little more explicit. Going back to readability and being able to communicate things well, we want to be able to have better names for the column titles and be able to adjust a few things. So a good thing here to be aware of is like reviews.rating is not a great name for an attribute because Python and pandas both use dots for syntax. So, in this case, you're pretty safe because if you were to like be missing a, quote and you misidentify a string, it's going to throw you an error. But you can imagine some circumstances where coincidentally this dot might have some meaning around this and can cause semantic errors that become very difficult to track down. So this is another good opportunity to illustrate the value of PEP8. So looking at this huge line of code here, we've got data.rename, and then we're passing it a dictionary of columns. So the dictionary is going to be using the curly braces at the end here. And then each entry in that dictionary, separated by comma, is going to be a key value pair. So one of the benefits of using PEP8 is relying on the fact that Python is a white syntax language, and you can create a dictionary in such a way that this now becomes much easier to interpret. So now we have data.rename, so our pandas data frame. We're running the rename method on that. That method takes in a couple of arguments. So the first argument is going to be the columns that we want to rename. And then we're going to set that equal to the dictionary, where we take the existing name in the data frame as the key. And then we use the colon here as the Python syntax in the dictionary to separate the keys from the values. So the key is going to be what exists in our data frame, and the value is going to be what we want to update it to. And then we provide a comma and a new line to tell Python that the next information that comes is going to be the next item in the dictionary. So we have reviews.rating. We want to change that to reviews_rating. We have reviews.text. We want to change that to reviews_text. And then we end our dictionary. And so that's the information that we're going to update as the first argument. And the second argument is an optional argument. And just like up here where we had to do data equals data and then that, Pandas offers you an optional argument where you can do true or false. And so if you pass true to the in-place parameter, then what that's going to do is automatically update the value of this variable to reflect the changes that you're recreating here. So we'll go ahead and run that. And then we'll run data.head again. And for those of you who may have missed that, so we have the triple asterisk here, and we want to change that to true. And then run this. And then we'll go ahead and run our data.head method. We'll just look at the first three values because by now we know we're looking at the correct data. And now you can see that unlike up here where we had just the name, we now have hotel_name. And instead of review.rating, we have review_rating. And instead of review.text, we have review_text. And just a quick note on style here. So when we separate the words of things in a variable or in a header or a category or attribute, there's a couple of different conventions you can use. This is what's called snake case. So the problem that this is handling is how can you have enough words in a symbol for something? So in this case, the symbol is the attribute and it represents the hotel names in the data set. How do you represent a symbol with a sufficient number of words without them cramming together? So for instance, if you had this and we ran this, we did this, what happened there? Oh, it might just be something we can only run once, but anyway, if this was crammed together, you can imagine, some words become very, very difficult to read. So we want to basically provide a space in that, but we can't give it an actual space, meaning like a white space character. And the reason why we can't do that is because Python is a white space syntax language. So the so 8 asks what the in place was for. So just like we did up here, where we ran this first, we ran this first, and it only just gave us back what we were looking at, but didn't actually update the data frame. We had to set it equal to itself again. So this is what's going to allow us to overwrite our original data with the data that we just want to look at. And pandas gives you an in-place parameter, and if you set that parameter equal to true, then it will automatically perform this task for you. Does that make sense? Or hopefully it answered your question. Okay, perfect. Let's see here. Oh yeah, so snake case is basically a convention that we use so that we can separate words from each other and still have sufficiently descriptive values for things. Another convention you can use is camel case. So I'll just show you that here. That would be where the first word is lowercase, and then the initial for the second word is uppercase. And again, this is called camel case. So you have a couple of different conventions. Usually in pandas, the convention is to just use snake case because it's a little clearer to read things, but definitely something to keep in mind. So that's kind of why we changed the reviews.rating to reviews_rating. All right, so next we'll get into the data wrangling process. But before we do that, I'm going to go ahead and add another poll for you guys. And again, this is just to take another data point and make sure that things are paced properly. Let's see here. So I'm going to go ahead and add this poll. And you should see that under the polls tab in just a second here. There we go. And it's basically how well you're understanding the topic. 1 for being I'm lost, 2, I understand a little, 3, 4, a little more, and then 5 is that you'd feel confident being able to teach this to someone else. So go ahead and take a moment to fill out that poll, and that'll give me an idea of how things are going, and maybe I can adjust the pace a little bit for you guys. Seems like everyone's understanding it pretty well, so I'll tailor to that. So the next thing we want to cover is the data wrangling and the processing. So this is going to be a very significant, if not the majority of what you're going to do as a data scientist. This is kind of an essential element of any project, and it serves 2 functions. One we kind of talked about earlier. Obviously, you need to make sure that your data is cleaned up and ready to process it through whatever model you have. There's a lot of decisions that have to be made. Like these little things here, like cleaning things up from a syntax perspective to make sure that we don't have to deal with any sticky semantic issues, all kinds of things like that. But there's additional things that you want to actually do to the data itself that is going to make that easier for you. The second reason is I have yet to find any better way to familiarize yourself with the data than to do the pre-processing. That's what's going to force you to look at as many anomalies in the data as you can find. And that's what's going to give you that kind of core understanding of what data you're dealing with. Like I mentioned before, the map is not the territory. You can be looking at a lot of data and it can become very overwhelming to try and understand, how accurate is this data? What kind of problems are in, this hundreds of megabytes or hundreds of gigabytes even, tons and tons and tons of data. How do you know that this data represents what it's supposed to represent? And the best way to do that is to just familiarize yourself with the data, and you're automatically going to do that as a part of the pre-processing. A lot of data scientists that I know, they kind of begrudge the data processing part of it because, I don't know about you guys, but one of the things that interested me about programming is that it allowed me to be a little lazier. I can automate things. I can do things much faster. I can get a lot more done. So when I have to do manual work, it can be a little stressful. It can be a little annoying. You put a lot of attention into it. But when I shifted my perspective towards, this isn't just necessary for technical reasons. This is my opportunity to drill down into the data, understand what it represents, and really familiarize myself with it. And that perspective really helped me improve as a data scientist, because it was actually something I became interested in. It changed my perspective to, okay, let's look at the data. Let's see what the data tells us. So we're going to go through some of those steps now. We're going to do things like cleaning up clutter from our initial text. We're going to look at how to work with variable assignment and Pandas syntax to make sure those changes persist, and then use Pandas map functionality to assign more relevant labels. And you kind of get into that where you need to change. Maybe you have a model that'll work better with categorical labels than numerical labels, or vice versa. So we want to kind of show you what these tools are for helping with the pre-processing. So the first thing we want to do is make everything lowercase, just like we discussed earlier in the slides. So we're going to take our data, and like we mentioned before, Pandas uses square bracket syntax to allow you to select columns that you want to process or identify or look at. So in this case, we're only passing a single value, so we don't need a list like we did up here, where we needed the double square, or the double square bracket syntax. So because we're not using a list, we only need to pass it a string inside of the double square brackets that refer to the Pandas data frame. And then we're going to refer to the string, and then we want to tell it that we want to lowercase all the string values in that column. So like if we're going here, we're selecting this column from our data frame, and then we're telling it any string that has an entry, which should be all of them. There might be some null values, but we'll get into that a little later. But anything that's a string in here, we want all of it to be lowercase. So we'll go ahead and run that. And you can see it's a similar situation as before. It returns a bunch of data to us. But if we try to return, oops. If we try to return this, you can see that there are still capitalization in there. So just like we had to do before up here, where we set data equal to data to strip out the other text that we're not interested in, or we had to use data.rename to change things here. We had to use the in-place parameter to tell it to keep these changes. We're going to have to do the same thing here. So when we just run, data review text.string.lower, all it's going to give us back is the modification of that. It's not actually going to change the data variable that represents our data frame. So to do that, in this case, because we're just looking at a single column and we're just looking at the variable and we're just doing that one process, we're going to set data review text equals to data review text dot string dot lower. So just like what we were doing up here, where oops, a little too far. Where'd it go? There it is. Just like here, where we called the data, and then whatever the output of that data was, we stuck it into the variable of the same name. That's how we updated it to just have these three columns. Similar to that, we're going to do the same thing here. So we're going to take data, referring to our data frame. We're going to select the review text, and then we're going to set that equal to the output of this line of code here. So when we do that, again, we're not going to get any output because we're just doing an assignment. But if we were to do, actually, I'll show that all to you down here. So the next thing we're going to do is remove non-text characters in a similar fashion. So this is getting into the regular expressions. Regex is a little bit like wizardry to me. I understand it enough, but there are definitely people who can use regex like magic, and it's very powerful. So it's definitely something that's worth putting some time into understanding. But understand it can be a very frustrating path. But generally, I'll kind of interpret this here for you, is, we're taking our data review text, and just like we did up here, we're setting the output of data review text dot string dot replace equal to itself, so that whenever we run this process, it's going to update it. And basically what we're trying to do is remove the non-text characters. So we're telling regex, and this is the syntax for a raw string in Python, and the regex library uses raw string input from Python as its signifier for processing what it's processing. So in this case, what it's processing is we're going to take every instance in the text. So anytime that one of these characters shows up in the review.text column as inside of a string, so a period, an exclamation point, a question mark, quotations, commas, hyphens, etc. Anytime any of these things show up here, so that's the first parameter of the replace, the thing that you want to replace, we want to replace it with this. This is our second argument. So it's basically an empty string. So we're going to take anywhere that a period shows up, an exclamation point shows up, a question mark shows up, and we're going to replace it with an empty string. And what that'll have the effect of doing is essentially dropping that out. And then, as we discussed earlier, we have our null values. So, if there's an entry that doesn't have a value, it'll just show up as NaN, which is the null value for Python. And what we're telling it is, again, we're going to take data review text. We're going to set it equal to the output of this line of code here. So data review text. Anywhere there's an NA, meaning someone didn't fill out a text review, they just left it blank, we're going to replace that with an empty string as well. And so we'll go ahead and run that. And so now that we've done these 3 steps, these 2 steps are the same, but we are actually updating the column in the data frame to reflect those changes. So now we've taken these 3 steps where we've lowercased everything, we've replaced all the punctuation, and we've gotten rid of the null values. We'll go ahead and run data.head again. And we can see that many of our changes have stuck. Sometimes it's not going to show you enough of the data. Obviously, you're not even going to be able to see where the NAs are missing because we've just replaced them with empty strings. And you can see now that there's no punctuation. Oh, interesting. Why did that stay in there? I'm going to rerun these. Maybe I forgot to run that. No, I'll run that. There we go. Okay, so yeah, basically what happens, and this can happen sometimes, if you just forget to run one of these, you can notice things like that, and it may even give you an error. Yeah, you definitely want to make sure that you run all of these, otherwise you can get some head scratchers. But yeah, now you can see that many of our changes have taken place. Nothing is uppercase, and we don't appear to have any punctuation. I will point out, though, obviously these ellipses seem like punctuation, but this isn't a function of the data itself. This is just something that the Colab IDE and many other IDEs that you use will do, and it's basically to just truncate the data. So this is more of like a technical, matter of what the IDE is doing rather than a reflection of the actual data. So that's why those are there, and they didn't get stripped out with this filter. So since we're working on a sentiment analysis project, let's have some fun and change the reviews from numbers to a more emotional human sentiment. And this will also give us an opportunity to show you some of the functionalities that exist. So this part of it isn't necessarily required to do the processing we want to do, but it's an important thing to show you that you can very easily change values if your model demands it. So again, we're going to refer to our data review sentiment. You can think of this like the variable. So we're selecting the column as a variable, and we're setting it equal to the output of the map function. And the map function, similar to the replace function that we used earlier, or the rename function that we used earlier, the map function will allow you, instead of just changing the name of the attribute or the column like we did up here, where we're renaming the columns, the column headers themselves, the map function gives you the ability to actually change the values within that column. So I'm going to give you guys about a minute to go through and change the value of what these things mean. Feel free to be creative. And then you also want to make sure that you create these values as strings. You don't want to just have them be raw text, because again, or not raw text, but just unformatted, uncategorized text that's going to cause a syntax error. So the way you want to do that, I'll give you a good example. So I'll say a 5.0 rating means that someone loved that hotel. So I'll leave it up to you guys to replace the rest of these. I'll give you about 30 more seconds. Shouldn't take too long. About 15 seconds. About 5 seconds. All right. So these are what I mapped them to. So a 1.0 rating is going to be mapped to hate, 2 is dislike, 3 is neutral, 4 is like, 5 is love. So now we run that, and you shouldn't get any return. You shouldn't get any errors. Of course, if you do, feel free to post those, and I can help you troubleshoot that. And after we've done that, we can get rid of the old rating column and get rid of any of our rows that are missing a review. So we're going to take, we're going to do data.drop. So we'll use the drop method on our data frame. The columns we're going to select is the review underscore rating. And then we're going to use our in place equals true to tell us that, to tell Python that we want to update the value of the data to reflect the changes that we've made here. And you can see that, you know, a lot of these operations are somewhat similar, and you know, that kind of speaks to the flexibility of Python. There's many different ways to do things. Not all of them are going to be the best way to do things. Some of them will get you by. You know, some will be better than others. It really depends on the context, and that's an intuition you'll develop more and more as you just kind of expose yourself to programming and you expose yourself to attempting these things. And that's why I highly recommend that you kind of hang on to this copy. You hang on to this slide URL so that you can think of this like a sandbox. You can go play in here and screw things up and you know, create errors and go research them and all those things. And it really gives you an opportunity to make mistakes, you know, without worrying about messing your computer up or anything like that. And worst case scenario, if you make a mistake so bad that you can't fix it, you can always just go back to the slides, go to this the link that refers to this, you know, the locked copy, and then just create a new one, and now you have a whole fresh sandbox. So definitely encourage you to play around with this Colab notebook as much as you can. The next thing we're going to do, so we've dropped the review rating column, and then we're going to drop the, wait a second, hold on here. Where did that happen? Oh, okay, yeah. So basically what we did here is we renamed we created a new column called review sentiment, and then we took the review rating column and mapped these values here. So the output of this would show, instead of a 1.0, it would show hate. Instead of 2.0, it would show dislike. So that's what the output here would show. And then we've taken that output and created a new column called review underscore sentiment. So if we do, data.head, let me see here. So you can see now that we have our index values, which don't correspond to these numbers here. You can see that they sequence up all the way through the total number of values in our data set. And then it changes it to, you know, like, love, etc. And if we were to look at the review rating, we can see that both of these things still exist in the data frame. And these are reflecting the numerical values. So now what we've done, I'm going to go ahead and clear that output out. So now what we've done is we're going to drop the review rating column. So we're going to drop the numerical output from this, or we're going to drop this column which contains the numerical values, and then we're going to update our data set to reflect that. And then we're going to look at our review sentiment column, which we created, that now has the hate, dislike, neutral, like, and love, or whatever values you chose. So we're going to select that column, and then we're going to drop all the NA values. So anywhere that there is an NA in there, or a non-value or a null value, we're going to drop that whole row and then update our data frame to reflect that. Any questions? Any concerns? Any errors so far? Okay, so now, oops, I'm actually go ahead and delete that. So we've run this. Oh, right. So we can only run this once because review.rating no longer exists, but I know that I've run that, so that's okay. So I've made sure that I run this, and we can know that because now it's giving us an error because we can only do that function once. And now when we do data.head, you can see that instead of the review rating column, we have a review sentiment column. So instead of the number values, we have the text values. And then you can also see that our prior processing changes are persistent as well. So we don't have any capitalization or punctuation or anything like that. So next we're going to take a quick look at the distribution of our label. So we're going to refer to our data frame and refer to our review sentiment column. We're going to run the value counts method. So that's going to give us a count of every time like appears, every time love appears, every time hate appears, whatever the case is. And then we're going to plot a bar chart with that data. So as you can see here, we're referring to PLT, which is what we the alias we created for matplotlib.pyplot, which again is what we're going to be using to visualize and plot our data. And with PLT, so referring to matplotlib.pyplot, we have a title method, we have an xlabel method, and we have a ylabel method. So these methods are going to allow you to pass a string as the argument, and that's going to provide the title, the xlabel, and the ylabel for that. So if we run this now, we can see that we have a label edit the string, an xlabel of edit the string, and then a title of label counts in the data set. So knowing that, what I want you guys to do is go ahead and update the values here for the triple asterisk of what you think a good X label and a good Y label will be. I'll give you about 30 seconds to do that starting now. And go ahead and feel free to just paste the code that you think will be a good X label and a good Y label. About 15 seconds left. About 5 seconds left. All right, so this is what I did. So our X label will be sentiments, and then our Y label will be the number of reviews. And the reason I chose that is because that's essentially the data that we're looking at. We want to count the number or the distribution of each sentiment that appears in our data. So the independent value is going to be the sentiments, and the dependent value, the Y variable, is going to be the number of reviews. And I'll change this real quick to the light theme so that you guys can see. Prepare your eyes. So you can see we have a title, we have our Y label, and we have our X label, and then we have each of our sentiments. And you can see that most people love the hotels that they stay in. Good chunk of people like the hotels they stay in. Most people are, a few people are neutral, and then about the same number of people hated and disliked their stay. That'll give you a quick distribution of what is going on with each of those. I'm going to go ahead and change this back to dark mode. There we go. So that's basically very quick and easy way that you can visualize the data. And this kind of gets more into the analysis and exploring the data. This is also very heavy in being able to familiarize yourself with it. And if you spend a sufficient amount of time going through the data, this is a good area to find problems. When you're doing the analysis, if you've kind of gone through the data and you start looking at visualizations and analyzing it, and you've really done proper pre-processing, there's going to be a lot more that sticks out to you if there's a problem. Your intuition will kind of say, oh, I looked through that data and I really didn't get the sense that this many people loved it. And sometimes your intuition is wrong. It's not that you should, always defer to your intuition. It's just that that's usually a good signal that you need to look a little deeper into the data, and maybe the reason why is because that part of what you pre-processed maybe had a disproportionate number of hate reviews, and that can happen randomly. It's likely to happen where you just have a chunk of one label show up somewhere. And so if you've done the pre-processing and you look and you stop and say, oh, okay, my intuition about the distribution of this didn't match the data. Let me go look back at the data. Let me get a larger sample, and so you kind of exist. There's a point in time in analysis where you're going to exist between the pre-processing and the analysis phase, and you kind of circle back around iteratively. So next, we're going to create the model that we discussed in the slides. So this is going to be creating the bag of words. So in this step, we'll take all of that text that we cleaned up and encoded, and encode it so that our model can understand it. So scikit-learn is the library that we'll use, and it has a number of different ways to do this. So today we're going to look at the count vectorizer. So we're going to import import the count vectorizer from sklearn.featureextraction.text. And then the max features is how many words we want to allow us to create columns for. So as discussed before, one of the difficult things about unstructured data is that every word is its own category, right? So you can have very, very long sentences and have very, very, very many categories. And that's one of the reasons why NLP can be very time consuming to process. You have all these different categories. So we're gonna say the max number of features that we're going to have over our entire data set. We're not going to go over 5,000. And what we're doing is creating a variable vectorizer. We're setting it equal to our count vectorizer. So that's the model we're using from sklearn. And then we're going to tell it, we're going to pass an argument to it that tells it that the max features is not to exceed 5,000. So go ahead and run that. All right. The next thing we're going to do is vectorize our reviews to transform sentences into columns. So by convention, we use a capital X, and this tries to basically refer to some matrix notation in mathematics. We try to stick to that as much as we can, but it's very hard to represent math symbolically in Python. But it's very easy to represent conceptually. So that's why we use a lot of words and things like that. But as a convention, we use a capital X. We set that equal to our vectorizer, and we're going to use the fit transform method. And to that method, we're going to pass our review text column from our data frame. And now that is basically a matrix that is going to exist in the variable X. And then we're going to pull all of that into a table. So we're going to create a variable bag of words using snake case. And we're going to assign to it a data frame that is created with pandas, where the first argument is converting our capital X matrix, so the thing that allowed us to vectorize our review text. So that's going to be our first argument. So x.toArray, and then the columns are going to equal vectorizer.get feature names. So basically, this will be the data, this will be the labels. So we'll go ahead and run that. And then we'll run the head method on our bag of words. And at first, this is going to be a little confusing because it's like, what does 00 mean? What does 0 a.m., 0 p.m.? What are all these numbers? But again, you just kind of want to look at the data. You have your dots of ellipses here where it kind of cuts things out. And this is where things start to make sense. It's like, okay, yard, yards, yeah, year, yearly. These are basically the features that we talked about. And they're arranged alphabetically. And you can see anywhere that shows up in an entry. So we know in the first entry, there's a 10 that appears, and there's probably won't luck out here, but let me see where there are other ones. And the reason why I say that is because there's a big chunk of data that's missing here. So a lot of these are just going to be zeros. And just like in our count vectorizer before, so you can imagine not every review is going to have 0, 0 show up in it. There are going to be very few reviews where that's going to happen. But if you can see kind of that middle chunk here, then that's where all the zeros and ones are, and you can see that this is a very, very large model. If we were to do a shape of this, so bag of words shape, we've got now 34,181 rows by 5,000 columns. So much, much larger than the original data we were dealing with. So next we'll get into some of the modeling. So now that we've got everything cleaned up and restructured, it's time to do the exciting part, which is the modeling. So we'll use our bag of words variable as our feature to predict our label of the review sentiment. X is the common convention, as mentioned, for designating our feature matrix. And the same is true for using Y for the target series. So once we've defined those, we can have our multinomial naive Bayes model learn from them just like we would in many other machine learning problems. So we are setting our feature matrix to our bag of words variable, and then we're setting the Y equal to the review sentiment column. So we'll go ahead and run that. And then we'll import and instantiate our model. So from sklearn.naive Bayes, we're going to import the multinomial naive Bayes, and then we're going to create an empty model under the variable model. So we have our variable model, and we're assigning an empty multinomial Bayes model to it. And then we're going to train our model. So we have a variable trained model assigned to the output of our empty multinomial naive Bayes. So model, and then we're going to use the fit method and pass it our capital X, and so our features, and then our Y, which is our review sentiment. And we'll go ahead and run that. And then now we can make predictions from our model. So after our model has learned from the historical data, we'll be able to introduce new or unseen reviews to it and ask it to predict the sentiment of those. So this is, again, something I encourage you to play around with. So you could add a string in here. And again, just to illustrate, so this is the triple quotes that I was talking about before. So anything that you, the nice thing about triple quotes is it allows you to span multiple lines. So you can just have one clear thing here to change. So I'll say something like, the pool was great. Here's how you guys find out that I don't know how to spell restaurant. Okay, the room was comfortable. There we go. So we'll go ahead and run that. And then we're going to have our capital X underscore test. We're going to set that equal to the vectorize to transform our test review. So we've set our test review here. And so we're going to transform that test review to an array, just like we did. So it kind of creates our bag of words. And we're going to vectorize that and stick that in a variable called xtest. And then we're going to create a variable called prediction and basically use our model to predict a label for it. So currently, my review is unlabeled. I'm going to basically do a quick step here to modify this into a format the model can understand, stick that in a variable, and then I'm going to create a variable prediction, and then take our trained model that we created above here. So this is our fully fit model that's trained on all the data we provided. And then I'm going to do the .predict method on that and pass in the new review to that. So we have test review, we have xtest. That's what's getting passed here. So this argument is basically the modified version of this that our model can understand. And then we're taking that output and we're sticking it into our prediction variable, and then we'll print our prediction. And according to our model, in my new review, the model has predicted that I liked the hotel. So I liked the hotel that I stayed in based on things like great and okay and comfortable, kind of, averaged out, the expression here to get a good idea of what the sentiment was. So alternatively, we can predict a probability for each sentiment. So we'll create a truncated variable here. So just a shortened version of probabilities. So probas equals trained model dot predict proba. And we're going to pass our xtest, and we're going to look at just the first index of that, and then convert it to a more readable output. So probabilities equals This basically just normalizes it. So takes the value divided by 100 to give you an average percentage for X in probas, which again, this is our, the first index of our X test here in our trained model. And then we'll create a variable labels, and we're going to set that equal to a list of the trained model classes, and then create a dictionary and see what this comes out as. So this is what's actually giving you a distribution of the probability of what it was. So, and you can see that this isn't in any particular order, but it calculated a 0% probability that I hated it, a 14% probability that I loved it, a 19% probability that I was neutral, and a 65% probability that I liked it. And you can see that dislike is absent here, so it didn't create a probability for that, likely because maybe it was a redundancy of hate. Actually, I'm not quite sure. Anyway, but you can see that it gives you those probabilities so that if you need to dig deeper into the model and be like, well, how much did he like it? How certain are we of that? You have the ability to look at a probability. So this has a take-home challenge. I highly encourage you to do that. You can go ahead and read through this, use a lot of the same concepts you've learned here, and and see if you can attempt this take-home challenge and the bonus advanced challenge. So we're going to look at a few of the weaknesses that our model has. Obviously we need to think about context and relative frequency. So we've outlined some of those basic building blocks for an NLP project, but you may already have some concerns like these questions about our process. So we'll consider context first. So when we parse all the words up, we completely lose the context, right? You now just have like essentially a list of words. And with respect to that model, one of the weaknesses here where it lacks context is both of these sentences would be weighted similarly, right? They would have similar outputs. The problem with that is these two things mean different things. This person hates motels and loves resorts. This person loves motels and hates resorts. And it's a problem that our model would see this as the same thing. So the way we can fix that is with something called an engram. So engrams are basically, each feature is a set of words rather than individual words. So it gives you more context of, what a word means with respect to the other words around it. So we get features like love resorts and hate motels rather than just love and hate and motels and resorts. And if you want some more information about that, you can read about engrams here, which again, I definitely encourage you to do. Engrams are a way that you would fix the problem of context. And then the relative frequency. So we can see here that there is a clear problem with comparing these two things equally. So 1 out of 5 words is phenomenal in the first example, and in the other we have 10 pages of words and phenomenal is mentioned once. So we need a way of looking at how frequently a word is mentioned to get an idea of its value. And so each one scores a 1 for phenomenal, and what we would use to correct that is what's called TF-IDF, or short-term frequency inverse document frequency. And this is a numerical statistic that is intended to reflect how important a word is to a document in a collection or a corpus of data. So the importance of a word increases proportionally to the number of times that it appears in a document, but then it's offset by the frequency of the word in the entire corpus of data. So I'll go ahead and link you to that as well. All right. And so hopefully our time today has you feeling more excited and confident to continue learning data science. If you have any questions about Thinkful or any of the material that we've covered, I'd love to get into those now. So as you're typing out your questions, I want to provide some additional information. One of the easiest ways to get your questions answered is to set up some time with our admissions advisor. I also highly encourage you to learn more. So Meetup and DataQuest, Kaggle.com, we kind of mentioned. DataQuest has some pretty good rudimentary free data science content. Meetup.com is great because you can actually meet individuals in your area that might have similar interests in programming. A great way to learn how to code is to kind of find a study partner and work through building something. Just get some ideas out on the table. Google's great for troubleshooting. So if you have errors or anything like that, you can go through and search and usually end up with something like Stack Overflow. It'll kind of walk you through how to fix it. And YouTube's a great source for tutorials. Again, the more you expose yourself to the information, the faster you'll get better at it. So any specific area of data science you get stuck in, or how to do this or that in Python, you can usually search that in YouTube and it will help you out. Let's see here. So basically, the admissions advisors are experts in all things Thinkful and can answer anything around tuition, enrollment, your local market, and more. I'd also encourage you to enroll in our 2-week free trial. So it's going to contain about 100 hours of actual program curriculum that you'll get access to. You'll have unlimited office hour access, so sessions similar to this webinar format. And then you also get lifetime access to our student Slack channels. So combining the webinars and the free trial is a fantastic way to learn more of the data science skills that we didn't have time to dig into today. We have many, many other webinars that cover topics in data science. So I highly encourage you to join those while you're going through the free trial. It can give you a lot of additional perspective and things like that, and also give you the ability to ask me questions about things. And yeah, basically you just want to learn as many data science skills as you can get access to, and we'll get into some of the questions that you have. Ivy's went ahead and posted a couple of links for you to schedule a call and fill out an application. And just a couple of things about these. The Q&A sessions in the Slack channel are run by the mentors. They do them pretty much every hour on the hour. And the student Slack community that you get access to is really great. One of the things that I think Thinkful does really well is not just teach you the curriculum, but also teach you how to be someone that's easy to work with. When you're in the data science field, there's a lot of remote work that you have to do. Many of your colleagues might not be in your physical geographical location, and using things like Slack, learning how to use things like GitHub really teaches you how to communicate effectively about these complicated topics. And the process really tries to encourage you to solve challenges that you have first with research and what you can do on your own and through the curriculum, and then reach out to your peers and see what you can figure out with them. And then if you still can't do that, that's where you have access to your advisors, your mentors, things like that they can kind of give you the nudge in the right direction that you need. So we'll go ahead and give it a little bit longer for any questions that you may have. And it doesn't necessarily need to be about Thinkful. If you have any questions about the field, we typically get a lot of good questions like what areas, are a good place to apply data science? What does the industry look like right now? What kind of growth we're seeing? Anything like that you have questions about, I'll be here. And then I'm also going to repost the trial link and the feedback survey. If you guys can give us feedback, that would be great. Again, it's not mandatory, but it definitely helps us continue to provide the content that you guys are interested in. Since we don't seem to have any questions, I'm going to go ahead and wrap the webinar up. But I appreciate all of you showing up and participating, and I hope it was useful for you. I'm going to go ahead and end the webinar now, but I will be around to answer chat questions for the next 10 or 15 minutes. So feel free to ask there, and thank you for showing up.